So, hello and welcome to the session from Quantmasters. So, in this technical session, we'll be going through a couple of programs which are often asked in interviews when it comes to technical aspects. So, the first program is related to something called bucket ID. So, let's begin without a delay and try to understand what exactly the problem is here. So, the idea of the question is in the input, the first thing that will be provided is n, which is basically the number of elements that will be entered, followed by the number of elements that will be entered. Let's say it is 10, 25, and let's say something like 35. These elements will be placed in different buckets. And the idea of the buckets is that each bucket is identified by the sum of digits of the number. So the sum of digit is 1 plus 0, which is 1. Here the sum of digits is 7, and here the sum of digits is 8. So you just need to specify the output as 1 space 7 space 8, where basically the input is 10, 25, and 35, and the output is 1, 7, and 8. So based on this input, it will be placed in this particular bucket. Similarly, based on this input, it should be placed in this particular bucket. So all you need to do is just based on each input value, just specify the output, that is the sum of digits accordingly. Once you have done that, basically stating that this particular input is placed in this particular bucket. So this is all that we need to do. The question is basically a very simple one. It's not difficult. And since there are three elements, let's say input will be 3 initially, so followed by the input 3, they will enter these 3 values for which we need to do this particular task. So to do this, we basically need to find sum of digits of a number. So let us first create a function which can calculate sum of digits of a number. Once that is done, we can then go ahead for the next step, that is do the same thing for each of the number that is input. So we're gonna start with C code. So all that we'll do here is just use attribute as usual, because we need to use it for printf and scanf. So let us create one simple function which creates or which returns sum of digits. So we'll take an integer input here. We'll just call it as int num. And this particular function is supposed to return the sum of digits for whatever input number is provided. So let's create a main function just to try this out first before we do the program in which it creates sum of digits for each of these number. First, we're going to create sum of digits only for one number to find out the bucket ID in which this particular input will be stored. So let us create this to begin with. So let's just say we'll call this particular function called sum of digits, and we'll send some value like 123. When we send that number, it will return a value. Let us say we'll store the returned value in a variable called result, and let us try to print that returned value for now, because with this code we'll then be able to create our code very easily. So let's start with this. Once we've got the number, how do we find sum of digits? So here's the basic idea. If you have a number like 1, 2, 3 and you want to find sum of digits, you need to take away each digit, and after finding each digit you just need to add the sum. So what we would require here is a new variable called sum, whose initial value, let's say, will be 0. So once we have this number, we need to take each digit and add it to sum. So as we know, the additive identity is 0, because when you add anything to 0, the result is whatever you have added. Similarly, the multiplicative identity is 1. When you multiply anything by 1, you get the initial number whatever you are multiplying with. So that is why in our case, since we are adding, we are giving sum as 0. If it was supposed to be multiplying each value, we're gonna have, instead of sum, something like product equals 1 instead of 0. This is the basic idea. So let's go ahead with this. Now here, I want to take the last digit away. To take the last digit away, simple step. All you need to do is take the number, perform modulus with 10. When you perform modulus with 10 by any number, here's basically what happens. Let's take the number 123. Let us perform modulus with 10. So remember, when you do n by 10, it's going to give you remainder. When you do n mod 10, it's going to give you quotient. So what we are expecting to get is quotient here. So let us try this out. 10. So we know 120 is divisible by 10. So I'll just take 10 times 12 is 120. So the remainder that we get is 3. Now 10 can't divide 3 anymore, so 3 remains as the remainder, and it doesn't continue dividing anymore. So the remainder can be obtained by using n mod 10, whereas quotient can be obtained using n by 10. What we need is n mod 10 so that we can add it to the sum. So what we are going to do here is we're going to try dividing n with 10, take the remainder. Whatever is the remainder, we're going to add it to sum. When you add it to sum will now become 3. Now, once you've added 3 already, let's say we have already added 3. The next thing I need to do is add 2. If I want to add 2, let's take this over here. If I want to take up 2, for instance, the basic idea I need to do, in short, is reduce this number to 12 instead of 123. So to reduce the number to 12 from 123, I need to take away 3. How do I take away the last digit? Because when I have the number 12, I can perform modulus by 10 and get the last digit, that is 2. So to do this, I'm going to divide the same number by 10. But this time, instead of taking remainder, I'm going to take the quotient. Because the quotient will be the entire number except the last digit. So what I need to do after performing modulus by 10 and storing the result back here is perform n by 10. This will give me the new number, which is only 12. So once I get 12, I'm supposed to repeat the same task again. Divided by 10, let's say 12. 10 times 1 is 10. You get 2 as the remainder, which is again supposed to be added to sum, which now becomes 5. And now the initial number, you have to remove 2 to make it just 1 to get this digit. That is why we are taking the quotient. So all that we are doing here, in short, is just this little task. So all that we need to do is take the number, and we should, let's say, as it is 1, 2, 3, perform modulus by 10. So let's perform modulus by 10. We'll store the result in something called remainder. After storing the result in remainder, this remainder I'm supposed to add to sum. So all that I'm doing here is perform sum plus, or sum equals sum plus remainder. So instead of storing it in a separate variable called remainder, we can directly add it. So here I don't want to store remainder in a separate variable because that takes extra space. To avoid this, all that I'm going to do is, here what we are doing is taking n mod 10, storing it in remainder, and then taking that remainder, storing it in sum. To avoid this, I'm just going to remove the concept of remainder here. Just take n mod 10, whatever value I get, and I'll directly add it to sum. So once this is done, my first step is done. If my number is 123, I'm taking the remainder, that is n mod 10, which gives me 3, and I'm adding it to sum. So sum basically becomes 3 now. So the next step from this is to remove the last digit of this number. To remove the last digit of this number, I have to take n by 10 and I have to store the result back in n. So when I divide the number by 10, I'm going to get 12 that is stored back in n. So n now becomes, instead of 123, as just 12, as we see in this step. Now once this is done, I'm supposed to repeat the same steps again. I'm supposed to repeat. This basically means that we are in a loop and there must be some condition for this loop. We are not sure what is the condition so far? We'll try to figure out what exactly is the condition. Now, n equals 12 is the number that we have. And what we're going to do here is, again, the same step, sum equals sum plus n mod 10. N mod 10 gives us the remainder, which is 2, which we are adding to 3. That gives us 5. The moment this is done, we're performing n equals n by 10. When you divide it by 10, you'll get only 1 remaining. Now we'll do the same step again. So whatever the condition is, we still don't know when it is false. We're currently here. So now let's go back here within the loop and let's go to this particular step. Over here, all that we need to do here is, again, go for the same step, sum equals sum plus n mod 10. When you divide 1 with 10, here's something that peculiar thing happens. 1 is less than 10. It's not divisible by 10 whatsoever. Any number that is less than 10 basically is not divisible by 10 as long as it is not a negative multiple of 10. So here, since no number when multiplied by 10 can divide it properly, minus 1 or 1 or whatsoever, so you're basically trying to divide it with 10 times 0 and you get remainder as 1 as it is. So the remainder will be obtained as the individual digit itself when there's a single digit. So even now the same step can be followed as well. So let us add this, that becomes 6. The moment that is done, our next step is n equals n mod 10. When you divide or when we see the quotient, it is 0 here. So n is now updated to 0. So now all the digits are utilized. There are no more digits left. So now is when you get to find out that you should stop doing this. You have found the sum of the digits. So the condition we will use is, just give the condition as while n not equal to 0. As long as n does not become 0, you will keep on doing these steps. When n becomes 0, you will stop these steps. That is when you find the sum of the digits. So this is the exact step that we are going to implement here as well. So we're going to take an integer value called sum, which is initially 0, and while number is not equal to 0, we do the following two steps. The first step is sum equals sum plus num mod 10. You don't need to use brackets compulsorily because modulus has higher precedence than plus anyway. So you can remove that. But for our understanding, I've just used the same. So followed by this, we just need to do n equals n by 10. We can also write the same thing in shorthand notation by writing n divided by equals 10 or sum plus equals num mod 10. Both can be tried out, but for our easier understanding, I'll leave it as it is. So once this is done, we'll return the final sum value, which consists of sum of the digits. So this is our simple sum of digits function, but what we need to do is the exact same program, but for n numbers that user will enter. So user will enter a number n, and based on that, whatever the number n is, user will enter n integer values for which we need to do the following step. So let us first read the value of n. Let's just read it as percentage d comma ampersand n. Now I'll state this. Please do not write any other statements when it comes to interviews like print, enter the number or anything, because your online compiler only understands the output that they are expected to read. The output they are expected to read are the bucket IDs, or in other words, sum of digits. You're not supposed to print anything else to make sure that compiler does not interpret that your output is wrong. So we'll not use any printf statements. Now, one peculiar thing you may observe is we have not created an array. Generally, we'll take something like int array of 100 or something like that. We have not created any such thing here. Instead, what we will be doing here is just creating a pointer called array, or you can name it anything you want. I'll call this as a pointer called bucket numbers. So let us try to see what this pointer helps in creating of an array. So all that we will do here is dynamically create an array of size n. So to do that, we're just going to use standard library.h header file. So from this is the basic thing we're going to do. As we know, standard library header file has a function called malloc, which will allocate any number of size or any bytes of size that we require. So we're going to allocate size of int multiplied by n, because for an array, if our array consists of 5 elements, that means each element of the array out of the 5 elements is going to have size of integer, either 2 or 4. So all 5 elements are going to have size of integers. So basically the size of the array will be 5 into size of integer. So that's basically what we are doing here as well. So we're just calling standard library header file, through which we are using a function called malloc, where we are asking the memory manager to give us enough size to store n integer elements, and we're going to return the value by converting to an integer pointer and storing in bucket underscore numbers. So now we can have the user enter the n values, and we can store it in bucket underscore numbers, which is our array. So to enter n values, we're going to take another variable I. For indices, so we're going to use something like for I equals 0, I less than n, I plus plus. So within this for loop, all that we are doing here is we read %d ampersand bucket numbers of I. So it's just an array that we have created using malloc. There's not much of a difference. So now we can access it the same way as expected. So since there's only one statement, I don't even need brackets. So once all the elements are entered, we need to find the sum of digits for each of the number and print it on screen. So we're basically going to take the same for loop again, but this time instead of scanf, we're going to use printf. And instead of again, it depends whether in question they are using tab space or just a space. So if they're using just a space, please use one space. In the question, if they specify as tab space, please use tab space. So all that we need to do here is send bucket numbers of I to this function, get back the sum value and print the sum. So we're just going to call sum of digits, and we will send as input bucket numbers of I. That's it. It's just about 20 lines of code that we are running. Let's see if it works or not. Let's compile our code. So I think I have misplaced the name of the file. So it is code in lowercase. So let's compile code.c. Let's see if we have any errors. There's one error here. I have made it as n instead of num because we have read the input as num. So let's update this to num as it is. Now let us compile again and see whether it works. There's no error so far. Let's try executing it. Let's say we give 4 numbers. Let's give 10, 11, 12 and 13. So we are getting the sum of digits as 1. For 10 it is 1. For 11 1 plus 1 is 2. For 12 1 plus 2 is 3. For 13 1 plus 3 is 4. So this is our basic simple program. Now in the input, if the constraint is that user can enter a very huge number, instead of just int, we need all these values, that is bucket numbers, to be stored as a long int. And similarly, since it will be long int, we need to create an array of the same size as well. And whenever we are reading long int, we're going to use %ld. In other words, if they specify that you're only supposed to enter positive numbers to a very large value, we can use %lu, and we can have this as unsigned long int as well. So this will make sure only positive numbers will be stored here. So by ensuring that only positive numbers are stored, you can also make sure that in your program you will be able to clear off the test cases when larger numbers are entered as input as well. So let's go ahead and just observe this once. If your input states that you can only enter 0 to a very large value, use unsigned long and make sure that whatever value you're entering is stored as unsigned long using the format specifier %lu, and whenever you send this number to sum of digits function, read it here as unsigned long int as well. So by making sure of this, you're ensuring that your numbers huge value is retained without losing it. So this also can be one of the test cases that you can easily try to solve. So this is the simple solution for the first program. I will replace it back to int, because when you're working through a 32-bit compiler, int itself takes around a huge value up to lakhs, which may as well cover it. But if the input value is much larger, then you can definitely go for unsigned long int or just long int in case negative numbers are also entered. So this is the simple program to find which bucket each input is stored in. So let's go on for the second program here. So the idea of the second program is that your input is a large number. Let's say your input is something like 2, 3, 5, 8, 9, 0. This is your input. So when you receive such an input, or whatever input number it may be, what you need to do is print output by modifying each digit. And let us try to observe what exactly are we going to modify each digit as. So in this program, the question states this simple idea. You take an input, you read each digit, and if the digit is even, even here considers 0, 2, 4, 6 and 8. Odd here considers 1, 3, 5, 7 and 9. This is the whole scenario. So when you get a number that is even, all that you need to do is add 1 to it. So let's take 2, let's add 1 to it. Let's take 8, let's add 1 to 2, it becomes 3, add 1 to 8, it becomes 9, add 1 to 0, it becomes 1. Similarly, take for odd numbers, instead of adding 1, you subtract 1. For even numbers including 0 is the question. In the question as it's stated, we add 1. For odd numbers, whatever we get, we subtract 1. Here also we subtract 1. Here also we subtract 1. So this is the output that is expected. Now, this seems somewhat close to logic when we compare it to the previous program, because in the previous program we found out each digit as well. Even here you're supposed to find out each digit as well, but the thing is, we are supposed to print it from left to right, because when we start with this, when we find out what is the last digit and we modify it, we get 1 here. And when we find out the last second digit and modify it, we get 8 here. So I'm not supposed to print 1 first, I'm supposed to print 8 first. So let us try to figure out what sort of logic can we apply, or what sort of modified logic should we apply from the previous program. So here's the basic idea. Let's take a simple number for us. We'll take 2, 3, 9 and 0. So we have taken this number, and we know that we can easily get the last digit from the number. So again, we know that we need to do it multiple times. So I'm just going to take a while loop, a condition. From the previous program, we also know the condition when the number becomes 0. That is when we need to stop. That is from the previous program. So I'm going to give the condition as while n not equal to 0. This is our looping condition, and this is where we're going to write the code to find the second number. So to do this, let's start with the first step. I'm going to take the last digit, and once I take the last digit, whatever I get, I need to figure out whether it's even or not. So to find out what is the last digit, I'm going to take a variable called remainder, which is going to store n mod 10. So the moment I get remainder, which is n mod 10, I'll get it as 0. So whatever this remainder is, first I'm going to check if it is odd. If remainder mod 2 is not equal to 0, you know that it is odd when you divide it by 2, the result is not 0. So here when you divide 1 by 2 or 3 by 2 or 5 by 2 or 7 by 2 or 9 by 2, the result is non-zero. So when I or in our case, if remainder mod 2 is non-zero, basically our number is odd, then we're supposed to add 1 to it. So all that we're going to do here is just perform remainder plus equals 1. We are adding 1 to it. Else, otherwise, the condition is subtract 1. So otherwise, all that we're going to do here is remainder minus equals 1. So this is the basic logic. That is, if it is an odd number, you add 1. Sorry, one small mistake, students. We are supposed to do the very opposite of it. So if it's an odd number, we're supposed to subtract 1. If it's an even number, we're supposed to add 1. So that was a slight mistake from my part. So let's update this. So in this case, since it is an odd number, we're pretty sure that anything when it is divisible by 2, result is not 0, it's odd. We subtract 1. So 9 becomes 8, 3 becomes 2. And when it is not divisible by, or when it is divisible by 2, or in any other case, we just add 1 to it. So that is the basic idea. So after getting this remainder, in the first case, when it is 0, we get 1. Because it's not divisible by 2, we increase it. So, sorry, when you search that if it is not divisible by 2, it's non-zero, so it goes to else. You get remainder plus equals 1. Let's see if that logic is correct. We'll check it while coding once to test our test cases. So when we add 1 to it, let's say we get this as the result. Now this result I'm going to store in some value called final. Let there be a variable called final. Please don't use final as a variable in Java. That is not going to be possible because it's a keyword. But in C we can do that. So let's say final is equal to, I'm going to store this particular value. So once I store this value, I'm going to take the next step. 9 here is not divisible by 0. So we reduce it by 1, we get 8. So when we get this number, I'm gonna need to somehow update 1 to make it 81. To make 1 as 81, all that I'm gonna do here is, whatever I get as the number, whatever I get here, this particular number, I should multiply it by 10 and add this number. So let's see if it works. 8 is what I'm getting. I'm gonna multiply this 8 by 10. I'm gonna add 1 to it. So when I do that, I get 81. Likewise, when you get the next digit, if you do the exact same thing, for 3, it's gonna become, as we know, 2. So can I also take 2 and multiply it by 10 and then add it to final? I cannot do that because when I multiply 2 by 10, it's gonna become 20. But what I'm supposed to make this 2 as is 200. I'm supposed to make it as 200 and then add this number 81. So let's try to figure out how exactly to do this. Because this is not a typical program where you're reversing a number. When you're reversing a number, you can literally multiply the remainder or reverse value, whatever you get, into 10 and add this number 8. That will make it 18. I'm not supposed to make it 18. I'm instead supposed to make it 81. So what we can have on the other hand is another variable called count, which is initially 0. For each number you get or for each digit you get, we increase the count. So let me first write down the basic code that we have created so far. I'll delete this function. We're going to do this directly within our main function. So we're reading only one value n. I'm going to take I for looping, and we'll also take result to store the result, which initially I'll make it as 0, and I'll also take count as 0. So let's say these are the 4 variables I require. So here's basically what we need to do. Let's create a condition while n not equal to 0. First, let us read the n value. So let's take scanf %d ampersand n. So when we've read the value, until it becomes, we repeat some steps. Now what are the steps we repeat? This is the exact steps. So we're first going to take the remainder, which is equal to n mod 10. When we take the remainder, we're going to check if remainder is odd, that is remainder of 2 not equal to 0. If it is odd, we perform remainder minus equals 1. Else we add by performing remainder plus equals 1. Now this remainder result, whatever we have in this case, I'm supposed to store it in our resulting value called result. So here when I use 8, when I take the next value 8, I'm supposed to multiply it in such a way that it becomes 81. When I take the next remainder 2, I'm supposed to multiply in such a way that it becomes 281. So for the first digit that I take, I should multiply it with 1. For second digit I take, I should multiply it with 10. For the third digit I take, or in other words, let me just try to change this slightly so that it's easier. Multiply this particular number by 10, that is becoming 80, and add it. Similarly, for 2, whatever I get, I'm supposed to multiply it by 100 and add it over here. So basically, the number you get here must be multiples of 10, and you should store that result in another integer value. Now, you can make these steps a little simpler if required by storing this in a character array. So the point here is, what we could do on the other hand is store whatever result we get in a character array as it is and print the character array in reverse. So one way is to multiply each number by 1, 10, 100 and add them, or store it as a number and then reverse it. There are multiple ways to do this. For now, I'll just state the simple ways. One, you can reverse the number here itself and store over, that requires a lot of steps. Another one, you can take each digit and store it in a character array. If you store it in a character array, you need to print that array in a reverse order. For example, if I store the resulting value of remainder here as 1 in a character array, then I can store the next value here which comes up as 8 in a character array, and the next value which comes up as 2 in a character array, then the next value which comes up as 3. I can store this in a character array and I can print this from reverse order. That is one way. The other simple way is store it in another particular array and then reverse it as well. So we're going to try our simplest method. What we will do here is this particular order. So we're going to create another variable called count in our case. This particular variable count, here's exactly what it does. You have one simple task here. Initially, let us try, because it's the first time we are trying to solve this problem. So let us give the count with a value 0. So all that we're going to do here in short is, every time you get a number, let's say the number you get here is 1. To make sure that this is the first number, we're going to multiply this 1 with 10 to the power of count. Just multiply it with 10 to the power of count. Count is initially 0. So 10 to the power of 0, we know it is 1. So 10 to the power of 0 is 1. So 1 is multiplied by 1 itself, which is equal to 1 itself. So that we will store it in the result. So result will be 1. After this step, let's go for the next value. The next value we get is 8. So by the time we go to the next value, we're going to increase count by 1. So just remember, at the last step before going to the next value, we increase count by 1. So before going to the next value, we're supposed to store the remainder added with, or sorry, remainder multiplied with 10 to the power of count. To calculate power, I will be using #include math.h. The reason I'm doing this is to avoid multiple repetitions. That is, to avoid storing it in a character array and printing it in reverse, or to also avoid storing the number and then printing it in reverse by calculating reverse again. So let's just multiply it with power of count comma, sorry, power of 10 comma count. So this will give us 10 to the power of count multiplied with remainder. This we're gonna store in result. Now when I get the second value 8, I'm going to do the same thing. 8 into 10 to the power of count. Count is 1. So 10 power 1 is 10. So that will give us 80. So this 80, I'm supposed to add to the result to make it 80 plus 1 as 81. So to add to the result here, we know since we are adding to result, even this step needs to change as result equals result plus. And first time this result should, since we are adding, it should have additive identity. Additive identity is 0. If we are multiplying, let's keep it as multiplicative identity, which is 1. So that is basically it. Now once this is done, let us go for the next value, that is 3. So with 3 we're getting 2. When we get 2, count is again increased by 1 by the time to 2. So this 2 will be multiplied by 10 to the power of count, which is 10 square, that is 100. So when you get 10 square, which is 100, that is 200 will be taken out. That is added to 81. That will give us 281. Then in the final step, we get 2, which is added to 1, which becomes 3. By the time which count is also increased by 3. So this 3 is multiplied by 10 cube, which is basically 1000. So when 3 is multiplied by 1000, you get 3000, which when added to result becomes 3281, which is exactly what we are supposed to print. So let's see if our output comes up correct in this case, or if it comes up to be wrong. So let's try to compile this code. I have one error, that is remainder is undeclared. So let us declare the variable remainder. Now let's try compiling this. Of course, I need to link math library because we have included math header file. Now that it is compiled, let's execute it. Let's give a number, the exact same number we tried in our case here, 2390, and let's see what exactly happens for 2390. If you type it and press enter, it's somehow going for an infinite loop. If you can observe this, that's because we've made one little mistake in the code here. That is, after performing n mod 10, we did not reduce the number, because the condition here is after performing n mod 10, only when I reduce the number by one digit, I will have only 239 in the next step. So that is why at the end of it, I need to perform n equals n by 10 as well. Now that we have done this step, let us try compiling it and running it. Let us give the same number 2390. We get exactly 3281. This is your simple program here to take each digit of the number, increase it by 1 if it is 0, 2, 4, 6 or 8, and decrease it by 1 if it is 1, 3, 5, 7 or 9. So these were the first two programs that we could solve in this session. So for more such problems, for more such programs that we have already done, please do check out our YouTube channel. There's a lot of programs that we have done within technical. There's a lot of questions in aptitude and verbal as well that have been solved. If you would like to go through our program as well, do check the description of the video and you'll be able to identify the links and the details for our program, which you can go through for the best placement preparations. Thank you and have a good time.